Welcome to part 2 of the webinar, Using IT Analytics to Improve Customer Experience. This is Charlie Rich, VP of Product Management at Nastel Technologies.
If you notice on the screen, it says simplicity from complexity. This is going to be the theme of what we speak about today. Our IT world, our jobs, our life are getting more and more complex as more and more technology is added, and it becomes very difficult. From an IT perspective, there are just so many events that we receive a day. It's an onslaught. How do you make that easier? How do you make it more simple to manage and improve our work life, our regular life in general? And that's what we're going to talk about today. So the key to this is mastering your transactions. Now you can see this chaos, this maelstrom of events here. We have them coming in from end users, application servers, other management tools, middleware, which Nastel is justifiably famous for, our capabilities with MQ, data power, integration bus, and so many other environments and mainframe. We even have clients that send us data feeds about money movements, cash and credit in and out. Well, this is a mess. This becomes very, very difficult unless you look at mastering your transactions. Now, the way we approach this, I like to use an analogy to describe this. One of my favorite television shows is CSI, Crime Scenes Investigators. And what they do is they gather the facts. And these can be, is there gunshot residue, is there fingerprints, they put that little violet light on, is there blood? Think of those as events. We can have thousands and thousands of those things, and it's difficult to solve the crime, or here in our case, master your transactions and improve availability and make customers happy. Well, the next thing a detective will say on CSI after they've gathered all the evidence is put it in a timeline. By putting it in a timeline, you know what happened, where it happened, who benefits from this as well. Now you have a much better understanding and making it easier to solve the crime. Well, we refer to that as stitching your transactions. Taking all these events that have occurred and putting them into a much more manageable piece that's more simple. And I think that's the beginning of how we can start to take complexity and make it more simple. Let me explain how we do that. Now, that occurs using something that Mylon spoke about quite a bit in his presentation, which was analytics. Now, the analytics that I'm referring to break into 5 categories. So we start off with transaction analysis, and this is tracking what happened, the transactions, and then stitching them together. And some of the things that we do that are pretty unique and advantageous is the ability to track transactions across tiers, to examine payloads, to handle long-running transactions, and put this all together into that timeline with that meaningful picture that makes things more simple. Of course, logs, everyone does as well, but we do some unique capabilities here in terms of correlation, sliding time windows, anomaly detection. Then let's make this visible. We use what's called application topology. So that's a way that you can visualize what happened and see where and have a good understanding of your situation. So that's the IT side. Now let's take a look at the business side. The most important part of this, the last one here, is our end users. Understanding if they're happy, if they're getting great performance, and when there is latency, breaking down those requests into the components, finding where the problem is, relating that to the server, the back end, be it a Java server, or middleware, or a mainframe, and finding out perhaps what's causing the latency. Then we get to something really interesting. I find this fascinating. What if we take the IT transactions that we're discovering and we map them to business objectives? And we call this business process mapping. And this is a way for more folks to get involved and collaborate, not just the IT, but the liaison to the business as well. And in this way, they can understand, okay, IT is humming along, this performance is great, but am I accomplishing my business objectives? Am I getting more orders? Am I making more money? And these are a way of tying their metrics to what IT is managing and auto-discovering. So this is how you get it done. We'll take a look here at the technology. So under the covers here, we have our data connection layer. And this is where we ingest a wide variety of information. These can be transactions in the, of course, Java, .NET, but then also JMS and MQ and data power and integration bus and even IBM mainframe CICS transaction server. All the app servers, mainframe Z, messaging middleware, which of course Nastel's very well known for, log frameworks like Apache Flume, Log4j, SL4 4j, syslog, many, many others, Java, clustered computing frameworks like Spark, and REST APIs. So a lot of information. But if we just stop there, this is really analogous to, hoarding. We just got a bunch of events. What good is that? The more important thing is what we do with that, and that's the analytics that Milo mentioned quite a bit in his presentation. So let's look at a couple of aspects. First thing is we have two grids. We have a real-time and a historical grid. So the real-time is an in-memory analysis of events that come in. They're time-ordered, they're grouped together, we analyze them, we run queries in parallel, and we have a really fast data analytics function that happens before data's even to disk. Sometimes it isn't, it's just purely in memory. We have a second grid that's for historical analytics, and this grid uses NoSQL, in our case currently Cassandra and Solar from DataStax, and we can combine this data in motion, as it's sometimes referred to, or data at rest, real-time and historical, and provide a very rich set of analytics. We're tracking and stitching this as it happens, and then we visualize, as you can see up here, the results of this. To make this easy to do, we have an English-like query language that makes it simple for a user, not just an IT user, but a business user as well, to ask questions of the data, or to even subscribe to questions for real time. So this is a way you can interact top-down with the system. You've got all of this analytics happening in the background, and then fast data is ingested from many, many sources. Okay, enough on the IT here. Let's take a look at how this is applied in the business. So here are a number of actual use cases of some of our customers. We have a number of very large financial services clients, many in the Fortune 50. One example of one here is a financial services institution that needed, like many do, to reconcile their books with the Federal Reserve every day for funds transfer. Now, this particular institution was reconciling over $1 trillion. Yes, you heard me right, $1 trillion a day. This is pretty mission critical, I would say. And this goes way beyond your N-tier, architectures with web servers and Java and, a database. This is across the enterprise. Now, should they fail to reconcile, the penalty could be you can't open the next day. And instead, you need to replay the entire day's transactions. That's a tremendous impact, and it's a Wall Street event, something you don't want to have happen. Now, the problem they had was they couldn't prioritize. They were getting near their 4 o'clock reconciliation time, and there was still quite a few transactions to be processed. But not having any visibility into them, they had to do this in order that they occurred, and unfortunately were not able to make it. The capability we brought to them was one where we could view the payloads of the transactions so that they could make a decision and process the ones that were critical to be done today and postpone the ones that didn't need to be processed till tomorrow. Another financial services firm, also focused on managing risk, was using us and is using us to track actual or potential breaches in compliance. So they brought in the business compliance officers as well as IT. What they were doing were tracking the reporting of swaps. And this was very important under Dodd-Frank trade reporting legislation. What was especially fascinating about it was, in addition to bringing in both the compliance officers and IT, these were long-running transactions that crossed the firewall and went across to, in some cases, DTCC and others, who could acknowledge, negatively acknowledge, or radio silence. And we have the capability to understand those transactions, and even when a parent transaction spans off children, and the parent dies, we're still able to reconcile that all together as one long-running asynchronous transaction. Something many of the other players we know in the APM space, have some challenges, with. One of the reasons they selected us. Other clients are in the healthcare payment side. Many of them track electronic health records, EHRs, and do claims processing. They need to bring the two together by having the electronic health record. While they do the claim, they can do much more accurate claims processing. These folks have SLAs. Many times it's number of claims per second. And then they also have to adhere to HIPAA's 80-20 rule, where no more than 20% of your costs are spent on things other than patients. And IT falls under infrastructure. Others in retail doing real-time capture of user experience data from point of sale for analysis. And then we have telco customers who are working on order management systems. Many of them need to manage the order process, reduce fallouts, and reduce the cost of support. You can see some of our many clients over here. I'm sure probably every one of these is familiar. We work with Citi in over 110 countries, and we monitor their payment, cash management, funds transfer. I mentioned a number of the Blue Cross Blue Shield companies like Best Buy, where we're monitoring pricing that goes out to their all of their stores, and that's an important thing for them as well too. So I think with that, what I'm going to do is leave the world of PowerPoint, and I'm going to move over, and we're going to switch and actually look at some product in that regard. So we're looking at Autopilot Insight, and this is a dashboard that we have right here. And I'll just take you through a quick view of some of the things that you're seeing on here, and then I'll go into a couple of very interesting use cases. So this is a simple dashboard. We're looking at different countries here and their different activities and events. This view is used for summarization of what's happening. Here we've got a geo map where we're showing end-user response time monitoring. And over here we've got topology, and I know Milan spoke about topology quite a bit in his presentation. And important about this is discovered automatically and maintained automatically. And you're seeing web clients. We have their average lapse time with their connections to the different apps and the count of calls and health status as well. And you see the interdependencies of the web client with the different applications, databases, and queues. And a pretty substantial topology here as well too. Other visualizations that we provide in this, you can see here we're looking at, and these are some of these English language queries that I mentioned. Here's a scorecard where we're getting the number of events for the latest day, and we're grouping them. Another view from an IT perspective where we're looking at events, and we're looking at the memory that's on these servers. An analysis from the end user side over popular browsers as well. So many different questions you can ask or subscribe to. But what I want to do now is I'm going to do a tear off, which is a nice technique to spawn a child window that's full screen. And we're going to look at some of the end user situations. So let's go take a look at our users in Hong Kong. We see some red there. It looks like there's some issues. So I'm bringing up the end user monitoring, and I see first off a complete breakdown of the individual components in an end user request. And here we can see things like the first byte time, server connection time, response available, document ready, document download, document processing, page render. This is all the stuff that happens in the background when you click on a form on a web page that you might be unaware of. Now, we can take a look at the topology for that. And here I can see the topology specifically for the Hong Kong. So now for that web client, I have just a portion of the topology that relates just to that web client with its performance data and status. Or I can go in, and we know there's a problem. You saw this information here. Let's take a look at the probable root cause. Milan mentioned analytics and root cause before, and this is a way we can understand what's going on. So it looks like in our analysis, process payment is the culprit. This is the one that took the longest here And we can see an elapsed time of 37 seconds. And I happen to know we have an SLA of 3 seconds. So we have a method stack. This is a trace of, in this case, of the different Java methods. And process payment here took the longest. We can see here as well. So let's go into the performance statistics for this here. And then I can see memory, thread, JMX, CPU. I can see something very interesting here. This is my cache hit ratio. And over the last hour, I've only had 7 cache hits. That's horrible. That could very well be the reason why I'm having a problem. This might be my probable root cause. Now, as Mylan mentioned earlier, the thing you want to do is avoid a war room. So a probable root cause can lead you with enough information so that a specialist can go and start solving the problem without having that onerous war room and the time that it can often waste. And this way, you can reduce mean time to repair and improve your customer satisfaction because you're cutting to the chase, getting to the right problem, and fixing things faster. And that's where the analytics come in to that as well. Let's take a look at another use case. So here we've got our friends in Hamburg, in Germany. So in this first case, we looked at a problem that JMX reported. Let's take a look at our issue in Hamburg. So we're looking at this here. We see the different amounts of time that are used. See a lot of time here, a response time on 7 seconds. But instead of guessing, let's go take a look and see what our analytics tells us. So our analytics here shows us receive order took more than 4 seconds and that it's got an error. And it looks like this was receive order was writing to a queue, and I think in this case it's middleware messaging, MQ, and the queue was full. And we were rerouting to the dead letter queue. But apparently the application didn't have the smarts to read the dead letter queue to find that message. So we'll probably route this not only to the MQ team, but we'll route this to development, which might want to have another routine in there to look in a secondary location for their data. Again, we averted a war room. We analyzed enough information to lead the specialist to a resolution. Let's take a look at another use case here that we got. I'm going to go to Comac, which is not too far from where I am on Long Island. And let's take a use case over here for end user monitoring. Looks like some pretty long times again too here. Certainly longer than our 3-second SLA. Let's bring up the root cause of what's going on. And it looks like the event that was the slowest, more than 4 seconds, was TCP. So this tells us we had network latency. So now I can bring the network engineers into this as well, because it doesn't look like a specific failure. It looks like we just had a congested network. So we can get them working on this as well. So what I've done is I've shown end-user monitoring as a way of measuring how successful the business is in its applications usage by its customers by seeing how successful, how happy, what the experience is of these users, and then doing an analysis that goes right into where the problem is, where the latency is, and providing enough probable root cause that we can begin resolving this problem immediately. Now, another aspect of this, because I showed you this in a scenario basis, there's a whole lot more to end user monitoring than we just saw. So let's click on Hong Kong. I'm going to choose something different. We're going to go now into a deep analysis of end users. And without you having to learn any of our queries or any of this, we have an automated button that will generate queries for end user monitoring specific to Hong Kong. So let's click on that button. And here we go. And the analytics in our solution here, Autopilot Insight, is going to generate all of these queries and create a new dashboard on the fly based on the data it found for Hong Kong. So now instead of those 5 or 6 things we saw before, we've got an in-depth analysis of what's going on. And you can see we're looking at requests per minute. We've got end-user time breakdown, cache, TCP, request. We see how long DNS took, which is another one of those things under the covers that happens you might not be aware of. Other things here like average user response time, and we have a complete breakdown by time of day here for Hong Kong, and we can see where there was greater latency. Now, a fun aspect of our language here, it uses things like top, best, worst. And here's a nice example where we're getting the worst 10 events of the day. And it looks like most of these were the payment requests, and we can see those. But this makes it a lot more friendly and approachable a tool. Plus, the language isn't necessary to use. There's so much automation here that does this automatically for you. One thing you look at often here, top requests per minute. Here we're looking at highest first byte times. So a real good analysis of what's going on in all aspects of this as well. One thing you look at too would also be what browsers. I'm sure you've all seen problems where you're not having a problem, but the folks on IE are having a problem, et cetera. Or the Linux users are, but the Windows ones aren't. Probably actually the reverse of that in most cases. So there's our automated analysis for end user data. Now your own data gets in either through streaming using our REST API or the many collectors we have, or you can of course use our tools to just import and bulk upload your data. So we spoke quite a bit today about taking the complex and making it more simple. And we talked about the key to doing that was through mastering your transactions. And that's what we've done. Our automation, our topology discovery, our end user monitoring are all methods of stitching and tying those
Transactions.
together, making them more simple, creating a topology, as Milan spoke about, so we can visualize what's going on, and then a probable root cause that traverses those, that stitched together transactions, so we can avoid the war rooms. At this point, I would like to open up the floor for questions and see if anyone has some questions here. Okay, here's one question. The user asks, are you able to track transactions that morph and split? Well, the answer is yes. Now, the scenarios where that might happen, I guess I can tell where you're from by that, is an area where you're using a broker. So very often, a message will go into a broker like a data power or integration bus, and the message that went in there that you're tracking is now completely rewritten. And instead of one message coming out, you may have something that's morphed into a new one, or you may have multiple that come out. It splits into many and are routed to many locations. Now, part of the advantage that we have in our transaction tracking and our stitching is that we read the payload. We're not dependent on tagging the actual data itself, which means we can track a transaction as it morphs and splits. Someone asked, okay, where do you store all that data? The answer to that is we use a NoSQL repository. There's one called Cassandra, along with Solar for indexing. We picked Cassandra because we focus on time series data, and we felt the performance from our tests was
superior
in that environment as well. Though our real-time analytics happen in memory, and Cassandra is a separate part of that. So any other questions anyone else would like to ask? Okay, someone asked, can you track long-running transactions? Yeah, I think I spoke about that, but happy to answer that one again. Yes, long-running transactions are transactions that you're not necessarily blocking on. They're asynchronous. The transaction runs, you really have no idea when it's going to end. You may get an acknowledgement, you may not. Sometimes you get no response. And how do you handle that? And that's something our transaction tracking is really strong at, in that we can model this, understand the parent transactions, and when they spawn children, we relate that all together. And very uniquely, when the parent dies, we still can understand the children are alive. It sounds really horrible, but this is how it works. And then put that all together as a model of this long-running transaction. This is something that a number of our large customers found unique about our capabilities and was very important to them, especially with transactions that
spanned their firewalls and went to other companies.
Got another one here, and this one asks, this is an easy one, do you sample or track each and every transaction? And the question is, we track every single one. So we can show you aggregates like you see up here, but we can also show you the actual instances of each and every transaction. Now this data can be coming from a large number of places. One of the things I mentioned is collectors. We have wide variety. I'll just jump out here and show you just a sampling of some of these for Hadoop, Logstash, Flume, Kafka, JMS, syslog, JMX, servlets, garbage collection. We even have a simulator. In addition to that, we have all of the middleware, mainframe, Java servers, and many, many other different environments as well. Okay, I think I would like to run a very brief poll. So I'm going to select a question here. I'd love to get your responses, and I'll share it with the group. So the first one is, does your firm use end-user monitoring? And is that correlated or connected up to your back-end servers? Please respond, if you will. Okay, excellent. We can share the results. And it looks like we have about 60% that have an end-to-end system in that regard. That's good. And about, looks like 20 don't, so they must have an end user and doesn't connect to the back. And it looks like about 20 that don't have end user monitoring, at all. Let's do another poll, and this one's around transactions. Does your organization track, trace, and monitor transactions? So real simple, you can answer yes or no to that. Keep it open another second there. I feel like I'm on the election process here, and the polls will be closing soon. Get your votes in. Poll in progress. All right, that should be enough time. And let's close that poll, and let's share the results. So, okay, 2/3, 1/3. So it looks like about 2/3, 63%, track and monitor transactions, and about 38% are not doing that today. All right, so I got one more question here. How fast can you put together a new query or view it? Well, that's a good question. So I showed a lot of automation where we can automatically create this. And in fact, if you stream data to us, we will create a full dashboard, and you don't need to use any language or anything else. It just appears automatically based on the type of data you send. If you import data, say in this case Apache log file data, we'll automatically detect the format and we'll create all the presentation. Alternatively, you could enter the query using Jackal, or you could use a query builder tool, which is essentially a wizard that'll walk you through this. So the short answer to that question is you can do it real fast. Not hard to do at all. So another question is asking about talking interactively. So all of these are drill downs, so I'm not sure if that's what the user means, but I can drill down into this data and look interactively. So I showed you the quick and dirty, avoid the war room, let's go into the details. But we could also interactively, if I'm on the diagnostic side and I want to go into the details and not just get the answer, I want to find out for myself, well, I can drill into these and get more detail. So let's take a look at that first end user response situation. And I can click on response time available. And now, instead of going to my answer, I'm going to get a histogram. And the histogram here shows me the number of activities and then over time. So this is the shortest amount of time. And that's, we have the most activities. And then longer, longer, longer. And this is the latest. So we can look at this as an outlier, if you will, or an anomaly. So now I can drill into the anomaly for the histogram, and I can see that response available looked like that was our outlier, and I can see it had 18 events that were generated for that, and I can click on events, and now I have all the send receive pairs here. Request, receive order, save order, validate order. These are all of the activities that happen in the application along with their timings. And I have the messages they produced, and I have the method stacks. In this case, we're using Java, and we have the lookups to calculate the parse as well. Everything that you need to understand, and in this case, you didn't need to enter any queries. You just dove deeper into this as well. If you want to do different queries, you can easily change these things. So for example, here we're looking at relative show as topology. I can very simply change what I want to show this as, and now I've got a tabular representation of the details. So the queries are very flexible in that regard, and I can save them, here and I can store them. I can open up ones that I have already saved, and we provide tutorials and more information for that as well. So this becomes easy on the fly to use. As I mentioned, you send your data in and we immediately provide all the viewlets. As you learn more and more how to use this, perhaps leveraging our tutorial, you can walk through this and enter your own queries, or just modify the ones we have. It becomes pretty easy on the fly to use this. Any other questions anyone has at this time? Looks like I got a couple more. Okay. One of the customers asked about licensing based on the amount of data sources. No, the way we license this, it's based on consumption, the amount of data. It doesn't really matter the number of sources. In fact, most of the collectors that we showed before are free. They're up and available either from our website, but they're also available on GitHub. We're, or you can get a free t-shirt. But we're true believers in open source, and we've made a lot of the Autopilot Insight collectors or instrumentation, which you might think of as adapters, probes, or whatnot. We've made those available for free as GitHub projects that are open to the public. And you can write your own. You can use our REST API. You can use any of our clients. You can take our end-user monitoring, and all you need to do is put a little snippet of code on your application websites, and instead of monitoring your interactions as we're doing here with Autopilot Insight, you can be monitoring them with any of your custom applications. That can be done in minutes. Another question was how many graph types, and I think there's a never-ending list of different types of graphs that we have. You can see there, this is a geomap one. We have summaries, we have tables, we have scorecards, columns, bar, area charts. We have charts that do stack charts, quite a few. We're always adding more to this as well too. So there's a large variety. I think that's about it. I'd love to get your folks' feedback. Let me know if you'd like a copy of the slides, and we'll send those out. We're going to produce the recording, and we'll put it up on the Nastel Technologies website, and we'll make that available, if not today, then the latest tomorrow. So again, I want to thank everyone for their time here today, and I hope it was helpful, and let me know your feedback. At the end of this, GoToMeeting is going to have a slight survey. And please, we'd love it if you can fill out some of the information on the survey. Then ask some other questions that we didn't have time for in the polling. Thank you so much.